Alright, Geometry Honors. Welcome back to Unit 2A, Packet 2, Line and Angle Theorems. Alright, let's always start off with the countdown to the Geometry EOC. We're still at 9 months. Alright, so we have a full page of definitions. I'm going to try and break them down into sections. So the very first section is, I want you to draw a line in between transversal and supplementary. Alright, so that basically breaks up the definitions. These two are the main, like this right here is the main thing that sets up the line and angle theorems. After that, once I know I have two parallel lines cut by a transversal, that creates these relationships, okay? So I'm going to start off. When you have parallel lines cut by a transversal, it looks like this. So I could say that line AB, and I know that I'm signifying by lines because they've got arrows, right, is parallel to line GD. So you see how line AB and GD will never touch. They're parallel, right? So the transversal is line EF. Line EF is the transversal. So these two are my parallel lines. And this right here is my transversal. Alright. So two parallel lines are two lines that will have the same distance apart, equal distance, and they'll never meet. A transversal is a line that passes through the two lines in the same plane at two distinct points, point H and point K. Alright, so I guess I already answered this question right here. Name the transversal in the above diagram. It's EF. Line EF. Alright, so once you have parallel lines cut by a transversal, that means you create special angle relationships that will always be the same. So parallel lines cut by a transversal creates special relationships between angles. Alright, and those 6 special relationships are below the line. So here we're going to talk about them. Supplementary, corresponding, alternate interior, alternate exterior, same side, and vertical. And I'm going to show you an abbreviation so you can remember all 6 of these relationships in a second, but I just want to talk about the different relationships. Again, you probably know what these mean, and I'm just formalizing the definition for you. So supplementary angles are two angles that sum to 180. So you see right here 120 and 60 sum to 180. Also, supplementary angles are going to be two angles that form a straight line. So do you see how this angle right here and this angle right here forms a straight line? Two angles that form a straight line. And we know that because a straight line is 180 degrees, right? So if two angles sum to 180, they have to look like they're sitting on top of a straight line. Alright, corresponding. Remember, we've already talked about corresponding. It's the same relative position, right? So see how I have these two parallel lines cut by a transversal? If I cover up this point, let's look at this angle right here. We're going to call that top right. Do you see how we have a top left, top right, bottom left, bottom right? This is in the top right position, so the corresponding angle below down here is also going to be the top right. Do you see how they're both in the same relative position of the intersection? They're both in the top right position. We call those corresponding angles. Now, it doesn't necessarily have to be top right. I could say my top left and top left are two corresponding angles. My bottom left and my bottom left. But they need to be in the same relative position. Alternate interior angles. Again, what does that word alternate mean? Alternate, we're going to say opposite. And interior inside. So they're angles that are formed on the opposite sides of the transversal within these two lines. So do you see how L and M are parallel, and here's our transversal? Alternate interior are on opposite sides of the transversal, but within both of these parallel lines. So the name is kind of self-explanatory, alternate interior, alternate interior. This angle right here and this angle right here are also alternate interior. Which leads me into my next definition, alternate exterior. So alternate, again, for angle relationships means opposite, opposite sides. And exterior would mean outside the transversal. So you see we have our two parallel lines in our transversal. We have alternate exterior here. They're on opposite sides of the transversal, and they're outside the parallel lines. So these two would also be alternate exterior. They're on the outside of the parallel lines and on opposite sides of the transversal. All right. Same side interior. Same side obviously means same side of the transversal, right? And then interior we know means inside the parallel lines. So if you look, my parallel lines are L and M. And we know they're parallel because it tells us right here. Remember those arrows on the line means parallel? They're on the same side of the transversal and within the parallel lines, inside the parallel lines. So same side interior. And then vertical. Vertical angles, each pair of opposite angles made by two intersecting lines. So if I have intersecting lines, my opposite, like right here, this and this, are vertical angles. This one and this one are vertical angles. So they're opposite sides of an intersection. All right, go ahead and flip the page over. All right, I told you that acronym that it was going to help you memorize the special angle relationships. So remember, when I have parallel lines cut by a transversal, it creates, and why do I keep missing the E in creates? Don't tell anyone I do that. Creates special angle relationships. Angles have relationships too. All right, scavus. Sounds like a disease. Scavus. We've all got it. S-C-A-V-A-S. So, S stands for supplementary. C stands for corresponding. A, alternate interior. V, vertical. A, alternate exterior. And S, same side interior. Scavus. That helps you remember the 6 different types of angle relationships. All right, I'm about to do some origami with this packet, so get ready. You're going to take this blank page down here, and we're going to create 2 parallel lines cut by a transversal. So you're going to fold up the bottom side evenly about here. You see that? I folded it up. You're going to fold it over one more time. Make sure it's straight and lines up on the side. Alright, so I got 2 hot dog folds. They look like that. Alright, within these folds, I want you to draw your lines. Alright, what did I create with these 2 folds? 2 parallel lines. Alright, now what I want you to do is fold to make a triangle. So you're folding it like this to make a triangle. And this fold just created our transversal. Alright. So now that we have our 2 parallel lines cut by a transversal, we're going to number within each angle and identify the different special types of relationships. So let's start here. 1, 2, 3, 4. You see how there's 4 angles here. Now I'm going to come down here and write 5, 6, 7, 8. So we have 8 different angles, and all of them are going to form some type of relationship because we have the 2 parallel lines cut by a transversal. All right, let's look at our first one, supplementary angles. They add to 180. All right, let's find some examples from our angles on the bottom. Remember I told you that supplementary angles look like when they're sitting together, they're sitting on a straight line. So I see 1 and 2. These two are supplementary. Angle 1 and angle 2. All right, do we see any more supplementary angles? I see 3 and 4. Angle 3 and angle 4. Also, do you see how 2 and 4 are sitting on that transversal line? So 2 and 4 are actually supplementary as well. So I'm going to write that here, angle 2 and angle 4. Do you see any supplementary down here? You could have said 5 and 6. You could have said 6 and 8. You could have said 5 and 7 and 7 and 8. Any angles that are sitting on a straight line together would be supplementary. All right, corresponding angles. Oh, also I want to make sure I note that supplementary angles add to 180. That's what we know about them. That's what we're going to use to solve problems. They add to 180. All right, corresponding angles are congruent. Congruent means equal, right? All right, so let's find some corresponding angles. Remember I told you they'd be in the same relative position. So what's corresponding with angle 1? You see angle 1 is in the top left. So what's in the top left? Let me focus this camera. What is in the top left of the bottom intersection? What corresponds with angle 1 down here? You are correct. It is angle 5. So I'm going to write angle 1 and angle 5. They're corresponding. All right, what else? What's corresponding with angle 2? Angle 2 is top right. Angle 6 is also top right. So angle 2 and angle 6. All right, we also have corresponding angles for 3 and 4. 3 corresponds with 7. They're both on the bottom left. And 4 corresponds with 8. Now you know that corresponding angles are congruent. So angle 1 is equal to angle 5. If angle 1 is 20 degrees, angle 5 also is 20 degrees. If angle 2 is 160, then angle 6 is also 160. So you use these special relationships to solve problems. All right, something else that we now know, alternate interior angles are congruent. Alternate interior. Remember we said alternate was opposite, and interior means inside the parallel lines. You've only got 2 pairs of alternate interior angles here. If we're looking at inside the parallel lines, we're only dealing with 3, 4, 5, and 6. The word opposite means different sides of the transversal. So if I'm looking at 3, what's alternate interior with 3? It's got to be on the other side, and that's 6. So angle 3 and angle 6 are alternate interior. Now that means angle 4 and angle 5 must also be alternate interior. And again, that tells me alternate interior angles are congruent. So I know that 3 and 6 are equal, and I know that 4 and 5 are equal. This is just supposed to be a line, so you can kind of see the difference. All right. Vertical angles. Remember, vertical angles are opposite within the intersection, right? So I've got 2 pairs of vertical angles up here. I've got 1 and 4 and 2 and 3. They're on opposite sides of the intersection. So let me go ahead and write that here. Angle 1 and angle 4. Angle 2 and angle 3. All right, so I want you to try and guess, or try and show me what you know, and tell me what the vertical angles are down here. So pause the video, write out the 2 vertical angles. Okay, you should have written 5 and 8, 6 and 7. So angle 5 and angle 8, angle 6 and angle 7. Those are vertical angles, and you know they are congruent. Okay, I'm going to stop right here because I'm running out of time on the video. So go back to Schoology and open video 2.